Welcome to our lecture for Monday, April 17th. We are officially, now that we've talked about redox reactions, moving out of aqueous reactions and moving into the why of how chemical reactions happen. So if you recall from my little storybook of chemistry analogy, we started by talking about what atoms themselves were, talked about their subatomic particles, their general properties, their structures, and the quantum mechanical model of the atom. And then we use that information about what atoms themselves were to build compounds and molecules by looking at how atoms come together to form chemical bonds. So we had our different chemical bonding models. And then once we had an idea of how compounds were made, we talked about their composition, their formulas, their names. And after that, we were able to take compounds and specifically look at those compounds reacting with one another in solution. So we've kind of built from the ground up all of chemistry in the sense of starting from the atom, working toward now chemical reactions, which we just wrapped up. So we're beginning a new unit here, which is the, again, why that explains what happens in a chemical reaction. So today we are going to practice a little bit some redox reactions. We're going to look at how we could write a net ionic equation for a redox reaction. And then we're going to get into that why chemical reactions happen in the first place, which is our conversation about energy. So we're going to discuss energy, systems, and surroundings. And then we're going to get specific when talking about systems, surroundings, and energy for chemistry by talking about the total internal energy for a chemical system. And then we are going to look at the components that allow us to determine the total internal energy of a chemical system, namely heat and work. And we'll continue this conversation about heat and work and heat exchange and work done or by the system as we move into lecture on Wednesday. So this is the plan today, a little bit of wrap up of chemical reactions, and then moving on into the reason why chemical reactions happen, which we call thermochemistry.